I hope you have done it with yourself, but let me calculate all these things. So this is my mass M1 and length L1, and second mass is something called M2 and length L2, and this is confined into XY plane, and origin is at here 0. So this is confined in vertical XY plane. So obviously G is in vertical direction. So let's try to solve it. So before going to solve this particular problem, let's try to figure it out. What will be degree of freedom? So obviously if this particle will free, then I can put x1, y1, z1. If this particle will free, then we can put x2, y2, z2. And yes, both the particle is in xy plane. So what I can say z1 is equal to 0 and z2 is equal to 0. So here z1 is equal to 0 and z2 is equal to 0. But you can have another equation of constraint. What is another equation of constraint? This distance is fixed. So what is this distance? This distance is nothing but x1 minus 0 whole square plus y1 minus 0 whole square. That must be equal to L1 square. And the next equation of constraint is that this distance is fixed. You cannot say this distance is fixed. Okay, this is entirely different. You can just turn this M2 into this direction also. So the distance from M2 and origin is not going to fix. What is going to fix is that this particular distance. So if this particular distance is there, then you have x2 minus x1 whole square plus y2 minus y1 whole square is equal to L2 square. So these are the equation of constraint. And now if these are equation of constraint, how many degree of freedom is there?
So
how many degree of freedom? 2 degree of freedom. So we have our DOF is equal to 3 into 2 minus 4 is equal to 2 degree of freedom. So if there is 2 degree of freedom, then how many generalized coordinate we can use? We have to use 2 generalized coordinate. Very good. Now what we have to do? We have to just write the Lagrangian of a system. So obviously the first particle M1 is moving in plane. So I can write its kinetic energy is half F1 x1 dot square plus y1 dot square. The second particle is also moving in a plane. So I can write half m2 x2 dot square plus y2 dot square. And this is my kinetic energy of a system. And what will be my potential energy? The potential energy for first particle is minus m1 g y1. And for the second particle, this is minus m2 g y2. But obviously we have used these 2 constraints, but we haven't used these 2 constraints, isn't it? हम लोगों ने ये दोनों तो यूज कर लिया, but इसे यूज नहीं किया है. But before going to use this constraint, what we can see the symmetry of a system. So what will be this particular locus between the locus of mass m1? Which type of equation is there? Locus of mass m1 is what? क्या है locus of mass m1? Circle. So this is a circle of radius L. So now, if we are if we want to go into circular symmetry, then obviously r and theta are the basic coordinates, है ना? Now we have to define what is my theta. So what is your theta? We have to define with the vertical, isn't it? So this will be angle theta 1. And what will be the another theta? And what will be equation of this particular thing? ये किस चीज का equation? If you will see x2 and y2, this is again circle, but right now the center is at x1 and y1. So by assuming this as a center, we can say this is my radius, and so I can choose this as my angle theta 2. Now, what I can do, I can write x, y or x1, y1, x2, y2 as a function of theta 1 and theta 2. So let's try to go for this. So what will be x1? What will be x1? बताइए. L1
sin
very
theta
good.
1.
L1 sin theta 1. What will be y1? L1
Cos
cos
theta 1.
theta 1. Very good. So L1 y1 is L1 cos theta 1. Now, what will be x2? What is x2? Anyone? What is
Sir,
x2?
it will be x1 plus L sin theta 1.
Very good, very good. So x2 is equal to, you can see this distance, isn't it? You just want to see this distance. This is your x2. And this x2 is what? x1 plus this distance. What is this distance? This distance is x1 plus L2 sin theta 2. And this thing can be written as, what is x1? x1 is equal to L1 sin theta 1 plus L2 sin theta 2. And this particular thing is x2. Are you people comfortable? Yes. And we have y2. What is y2? y1 plus, बताइए क्या होगा? L2 cos theta 2. Isn't it? Same thing. This is your y1. This is your y2. So this is y1 plus this distance. And this distance is what? L2 cos theta 2. So y2 is equal to, we have L1 cos theta 1 plus L2 cos theta 2. आपको नजर आ रहा है ये? Okay, now it's clear. Okay, good. Now what we have to do? We have to just calculate x1 dot, y1 dot, x2 dot, and y2 dot. So once we will calculate x1 dot, y1 dot, x2 dot, and y2 dot, and if we will put, then what will be our dynamical variable? क्या होगा हमारा dynamical variable?
So theta 1 and
Theta 1 and theta 2. And now you can see how many generalized coordinate will be there? There will be 2 generalized coordinate. The first one is theta 1 and second one is all about what? Theta 2. So let's try to calculate this one. What is your x1 dot? x1 dot is equal to L1 cos theta 1 dot. What is your y1 dot? y1 dot is minus L1 sin theta 1 dot. Let's try to calculate this one. x2 dot. What is this value? L1 cos theta 1 dot plus L2 cos theta 2 dot. And now you have to just go for y2. So what is this y2 dot? Minus L sin theta 1 dot minus or L1, and this will, and again is minus L2 sin theta 2 dot. Okay, up to that everyone is comfortable? Okay, now we have to put all this thing here. So I am just going to remove it and then we will put all this value. So obviously the first term is very simple, x1 dot square plus y1 dot square. So what will be your kinetic energy? So first term is half m1. What is x1 dot square plus y1 dot square? Obviously L1 square theta 1 dot square, isn't it? You can take a square and you can take a square and add it. What you will get? L1 theta 1 dot square common, cos square theta plus sin square theta is equal to what? 1. So you have m1 L1 square theta 1 dot square plus the second term is more interesting, m2. Now here you have to go for x2 dot square plus y2 dot square. So when you are going for x2 dot square plus y2 dot square, you can just check. I can write this thing as A, this thing as B, this thing is C, and this thing is D. Okay, now you can check. What is x2 dot square? A square plus B square plus 2AB. Are you people comfortable? X2 dot
sir.
square is equal to A square plus B square plus 2AB. And y2, what is y2 dot square? C square plus D square plus 2CD. Are you getting my point?
Yes, sir.
Now, what will happen to A square and C square? What you will get? A from the A square and C square. क्या मिलेगा? Just tell me.
L1 square theta 1 dot square.
Very good. So that you will get L1 square theta 1 dot square. Very nice. Now from B square plus D square, what you will get?
L2 square theta 2 dot square.
Very good. So you will get L2 square theta 2 dot square plus there is a cross term. So which term is going to take common in both term? 2AB and 2CD. Which term is going to common? Just tell me.
2 L1 L2
Very good. 2 L1 L2 or
theta 1 theta 2
theta 1 dot. Very good.
theta 2 dot.
Theta 2 dot. Very nice. What next? And other thing can be here. What is this? Cos theta 1 and cos theta 2 for A and B, isn't it? Cos theta 2 minus. Here you can go for sin theta 1 and sin theta 2. Agreed? Great. So this is a huge kinetic energy expression, isn't it? By the way, what is this particular thing? ये क्या होगा?
Cos theta 1 plus theta 2.
Very. Sorry, this will be plus, not minus. This will be plus because minus minus is plus, isn't it? है ना? So what will be your kinetic energy? Your kinetic energy is half m1 L1 square theta 1 dot square half m2 L1 square theta 1 dot square plus L2 square theta 2 dot square plus 2 L1 L2 theta 1 dot theta 2 dot, and what you will get? You will get sine theta 1 minus theta 2.
Sir, it will be cos.
It will be cos. Sorry.
Cos.
Cos. Yes, that will be cos. Good. So that will be cos theta 1 minus theta 2. And now you can write this is your expression of kinetic energy, isn't it?
Yes, sir.
This is a huge expression. और ये आपके एग्जाम में आ चुका है ना? So this is very interesting. Okay. So now we can also write the potential energy. What is potential energy? Minus m1 g y1. What is y1? L1 cos theta 1. And again minus m2 g y2. So that value is equal to m2 g. And what is y2? Is L1 cos theta 1 plus L2 cos theta 2. So this is your potential energy. And we will solve this equation of motion when we will go for small oscillation and all this thing. Then we will try to solve all this thing. Okay? Clear है यहाँ तक? Okay, good. So up to this, everyone is comfortable?
Yes, sir.
So आपने ट्राई किया था? I think 2-3 लोगों ने ट्राई किया. I think they have done it correctly. So आप इसको चेक कर लोगे, ठीक है? This is cos theta 1 minus theta 2, है ना? Okay, let's go for our next problem. Next problem देखते हैं क्या है. Okay? Everyone is comfortable?
Yes, sir.
If you have any doubt, you can ask. Now, Anubhav, you can ask doubt. Where is the doubt actually? If you are there, Anubhav is there? Hello?
Absolutely clear.
Hello? Mhm.
Hello, yes, sir. Yeah, sir, it is absolutely clear, sir, now. It is
Now
absolutely clear.
you are getting it. Okay? Great. So अब आप लोग
Yeah, yes, sir.
okay, good. एक और problem करते हैं. Then we will then you are able to solve the previous year questions as well as your tutorial. So you can just go for a straightforward tutorial one. Okay? आप फिर उसे भी solve कर सकते हो. Okay, let's go for another problem. Chalo. So now let's go for this problem. This is very interesting. So I hope we have also calculated the degree of freedom of this one. So there is a table and there is a hole on a table and we have a mass M1 and another mass is absolutely M2. And M1 is constrained to move on XY plane. So M1 is constrained to move on the surface of table. So you can just say this is X and this is Y and this direction is Z1. Okay. So M1 and M2 attached to end of massless string. So M1 and M2 attached to end of massless string, where M2 can move in vertical direction. M2 can move only in vertical direction. And M1 can move on a surface of table. And M1 can move on surface of table. Okay. Now let's try to solve this particular problem. So first we have to calculate the degree of freedom. Yes. So what is degree of freedom in this particular problem? So if this particle will free, I can put this is x1, y1 and z1. If this particle will free, that is x2, y2, z2. I can put this as a origin. Okay. But this is not the story. The story is entirely different. What is first story? That z1 is equal to what? 0. What is second story for this particle M2?
X2 and Y2 is equal to
X2 is equal to 0 as well as Y2 is equal to 0. Yes? X2 is equal to 0 as well as Y2 is equal to 0. Now, what is going to happen? Is that only these three constraints are there? No. You एक और constraint है. वो constraint क्या है? The length of this string is going to fix. Then what will happen? X1 minus 0 whole square plus Y1 minus 0 whole square, and you can just take the root this one. So this is this length plus what will be this length? Z2 minus 0 whole square root under must be L. So can I write this whole thing as x1 minus 0 whole square, y1 minus 0 whole square is L minus Z2 whole square. Can we write this thing? Say yes or no. लिख सकते हैं ना?
Yes, sir, we can.
Okay. Then how many equation of constraint is there? 1, 2, 3. Both are same thing. So this is 4. So how many degree of freedom?
So it will be 2.
3 into 2 minus 4 must be 2. Okay. So how many generalized coordinate we needed? We needed absolutely 2 generalized coordinate. Okay. Now let's try to solve this particular. So first mass m1 is moving on a plane. So what will be kinetic energy? Half m1 x1 dot square plus y1 dot square. And second mass is moving only in the vertical direction. So I can write half m2 z2 dot square. Up to that, everyone is comfortable? And what is your potential energy for first particle? That is 0. The potential energy for second particle is m2z z2. m2z z2 with the negative sign. Why negative sign? I can assume this is my reference 0. So I can take it negative potential. Okay, great. Now, is that there is 2 generalized coordinate?
No, sir.
No,
There are
there are 3 generalized coordinate. Okay. And obviously you can see the first mass, that second mass is just moving in a vertical direction. So there is this Z2 is good. This is linear one. The motion of first mass is just a linear one. But sorry, second mass. The motion of second mass is just linear one. Let's go for the first mass. When I am talking about first mass, what will be equation of constraint? This is the equation of constraint. This is the locus of a particular mass m1. And when it is the locus of first mass m1, what is this particular locus? क्या है ये locus? किस चीज का locus है? बताइए. What is this equation? Anyone? What is this equation? ये किस चीज का equation है? Equation of circle. Where is the center? 0 and 0. But what is radius of this equation? Of this circle? L minus Z2. And which is constant or variable? Variable. So here your radius is not fixed. As in the earlier problem, you can see that your radius is going to fix. Here your center is fixed, but radius is not going to fix. So what I can do, I can put x1 is equal to r cos theta and y1 is equal to what? R sin theta. And then from here, I can go r is equal to L minus Z2. लिख सकते हैं ना? Yes. And I can transform this whole equation into which coordinate system? I can transform this whole equation into which coordinate system? Circular polar coordinate system, isn't it? So if we are going to transform this thing, then T is equal to half m r dot square r square theta dot square plus half m Z2 square. This is my kinetic energy. And what is your potential energy? Minus m2z z2.
Sir, first one will be m1 and second one will be m2.
Okay. First one is m1 and second one is m2. Okay, good. Now you can see, is that Z2 and R are dependent or independent? Z2 and R are independent or dependent? dependent, isn't it? You can see if Z2 will be bigger, then R will be smaller. If Z2 will be smaller, then R will be bigger. So these two things are just going to compensate each other. एक दूसरे को क्या कर रहा है ये? Compensate कर रहा है. So from here, I can write Z2 is equal to minus R dot. लिख सकते हैं? Z2 is equal to what? Minus R dot, or Z2 is equal to L minus R. So now what I can do, I can just put the value of Z2 here, then my Lagrangian is half M1 R dot square theta dot square plus half M2. What is Z2 dot square? Minus R dot square. So that value is R dot square. Okay. And then minus minus plus, and that value is equal to what? M2 Z. What is value of Z2? Is L minus R. This is my Lagrangian of a system. And now you can see how many generalized coordinate we are using.
So
How many? Two generalized coordinate. We are using
R
what?
theta.
Two generalized coordinate. What is that? R and
R and theta.
Yes. And now you can just check whether is that any cyclic coordinate?
Yes, sir.
What is cyclic coordinate here?
Theta.
Theta is your cyclic coordinate. Okay, good. So theta is your cyclic coordinate. So which quantity is going to conserve?
P theta.
P theta. So what is that P theta?
That's the angular momentum.
Angular momentum. In which direction?
Sir, in Z direction.
Very good. Good. What is expression of that angular momentum?
Sir, P theta is equal to del L by del theta dot.
Very good. So we can just check del L upon del theta must be equal to 0. So theta is what? Cyclic coordinate. Okay. And now del L upon del theta dot is equal to P theta. And that value is M1 R square theta dot. And that must be constant. That must be constant. And now we can go for equation of motion. What is this equation of motion? So can I write this thing? Just you can check it. M R double dot minus M R theta dot square plus, sorry, कुछ गड़बड़ है ना? Just check. Just ये भी तो आएगा. Sorry. Let me write it here. So now this will be M1 plus M2 R double dot. यहाँ से. Now this part have been done. Let's go for this part. So minus M1 R theta dot square. And now this part have been done. Now for this minus minus plus, that value is M2G must be equal to 0. So this is your equation of motion. Are you getting my point?
Yes, sir.
Hannah? Now take a homework into this particular problem. What you have to do? You have to calculate the value of Z0. Sorry, you have to calculate the value of omega of the first particle, omega of M1, such that M2 will hang. It is not going to move. M2 will hang stationary such that M2 will hang stationary at distance Z0 from origin or from surface of table. Are people going to understand what I am asking? You have to just calculate the value of angular velocity of m1. So it will just going to rotate such that m2 will just hang. Okay, just try to solve it as your homework. करोगे इसे? Just one liner है, कुछ नहीं. Okay. If Z2 will fix, then is that R will also fix? Say yes or no.
Yes,
If
sir.
Z2 will fix, then R will also fix?
Yes, sir.
Yes.
Because L
Yes,
is fixed.
because length is fixed, isn't it? So for given value of, so R is equal to L minus Z. So our Z is equal to L minus R. So if Z is equal to Z naught, what is value of R? R is equal to L minus Z naught. Okay. And this value is fixed, isn't it? This is not variable. Then what will happen? What will happen? बताओ क्या होगा?
Sir, Z dot will be 0.
Z. So this equation is R double dot. So what will happen? At R is equal to R naught, R dot is equal to 0 as well as what? R double dot is equal to 0.
0.
है ना? So you will put the value R is equal to R naught and then you can get the value of theta dot and just try to do this thing. 80% चीजें मैंने कर ली है, but finally आप इसको complete करने की कोशिश करो. So now you can go for your tutorial 1. Okay. Now you have to at least attempt yourself. I will just discuss all the problem of tutorial into next class and then we will go for the next level of analysis of Lagrangian. That is all about action and how you can use the equation of motion. This is in your examination trend. ठीक है? So from today point of view, I think this is
क्वेश्चन
okay.
में p थीटा की डायरेक्शन समझा दो, z वाला पता नहीं चला, z डायरेक्शन में कैसे आया?
ये XY प्लेन में मूव कर रहा है.
यस सर.
जब ये कोई भी पार्टिकल XY प्लेन में रोटेट करती है तो एंगुलर मोमेंटम की डायरेक्शन क्या होता है? परपेंडिकुलर टू दैट प्लेन. सो वो किस डायरेक्शन में रहेगा?
z. ओके सर, थैंक यू.
ठीक है. ओके, थैंक यू.
Thank you, sir.
Thank you, sir. Good night, sir.